I have one of my friends, like they were asked to complete solution chapter in 6 lectures. There also lectures are of 1.5 hours, right?
1 hour.
1 hour.
Yeah, 1 hour and then 4 times a week. But then it's like either 2 classes of chemistry some days and like 2 classes of physics, like that sometimes.
Okay. So like, okay. The number of hours are very less. Like 4 classes in the sense this means आपको तीनों subject पढ़ाते हैं.
4.5 hours per day, where like we have 5 minutes, then 10 minutes, 5 minutes kind of break after each class, and then 4 times a week. So 4 into 4.
Yeah. Okay. Fine. Achha, I get it now. Okay. 4 into 4. That means like 16 hours of lectures are there, right? 16 hours if I divide that by approximately. You're getting enough time there. So approximately you're getting 4. You can say more than 4 also. Okay. So, acha, Umar, you had one doubt, right? Yes, Umar, Assalamu alaikum. How are you? Can you hear me?
Yes.
Is that clear, or do you still have that doubt?
No, it's clear now.
It's clear now with that example?
Yeah. It's clear now.
Okay, fine. I mean, I was confused, like how to explain. Now you understand that, like, there is not a proper way of explaining that thing if you are understanding the words in a completely different way, right?
Yeah.
है ना?
I went on to Google and I searched it and I got the answer that I was looking for.
What was your confusion, by the way? I mean, I could not understand what you were saying that, okay, fine. I understand that solubility is inversely proportional to KH, right?
Yes, sir.
So now what you are saying?
I was saying, like, let's say there's a gas that has a higher solubility. Would it require more value of KH to make some changes in?
Would it require
more value of KH to make changes?
KH is what? It is a constant for a gas, no?
Yeah.
So KH is a constant. So how will you make changes in the KH for a particular gas?
No, would it require more KH? Like the constant value would be more for the gases which have higher solubility. That was my doubt.
ये आप इक्वेशन देके बताइए क्या आंसर होगा उसका. How can you have that doubt? वही हम पूछना चाह रहे हैं आपसे. If you are saying
now it's clear, anyways.
नहीं, but still, like I want to ask, like why you are having this doubt? यहाँ पे जब आपको ये भी पता है कि equation में like if solubility is inversely proportional to KH, then how can you say if I want to increase the solubility, then I need more KH? You can say that the difference between the KH values, if you want higher solubility and lower solubility, that difference will be greater, obviously, but है ना? For example, if I want to increase the solubility 2 times, I have to do KH also. I have to increase KH also 2 times. But if I want to increase the solubility 4 times, then I have to in this case, I have to decrease the solubility 4 times. Yeah? That means there will be greater difference will be there. But the value itself will be lesser. Yeah? If I compare these two things, let us compare 100 and let us compare 20, right? So the difference is greater, but the value itself is lower. You understand this point, yes or no?
Yes.
Okay, fine. So in the last lecture, we did something which was question, right? Question on Raoult's law, right? At the end. Now write the heading. Raoult's law as special case of Henry's law. Raoult's law as special case of Henry's law. In this, we will be looking at the similarities between Raoult's law and Henry's law. So the first similarity is that both of these laws are for fluids. Fluids means things that can flow. So fluid is not only liquid things. Anything which can flow, that is fluid. So gases also, they can flow from one place to another. that means these are also fluids. So both of these are applicable to fluids. So this is one of the similarity, but let us write the Raoult's law. So Raoult's law is always what? If I want the partial pressure due to B, it will be equal to its vapor pressure of pure B multiplied by mole fraction of B. In Henry's law, it states that pressure it is equal to Kh into chi B. Something that you can see which is similar here is that both of these terms are giving me the pressure. Both of these terms are giving me the pressure. They involve the term that is a mole fraction, right? And this also involves mole fraction. And there is a constant involved, and whose unit is also what? For vapor pressure of pure B, the unit will be obviously that of pressure. And the Kh also, it has unit for pressure only. It also has unit for pressure. Okay. Now these are the similarities that we can see. These are the basic similarities that you can see between Raoult's law and Henry's law. Both of these are applicable to fluids. Okay. The only difference is what? The only difference is the Kh, right? The Kh, the Henry constant, it becomes P naught B. The Henry's constant, it becomes P naught B. Now, one thing, if I look at the Kh, then I can say that if Kh is high, right? If Kh is high, that means solubility will be low. Solubility will be low. If I look at P naught B also, if I look at P naught B, that means if P naught B is higher, that means we have more vapor. And if we have more vapor, that means the escaping tendency or the molecules, these are escaping easily. And where are they escaping from? They are escaping from the solution. And if they don't want to be in the solution, that means what is happening? The solubility is decreasing. The solubility is decreasing. So those liquids which will have a higher P naught, higher value of vapor pressure in pure state, they will have lower solubility also. So this is also one of the point which is similar between Raoult's law and Henry's law. And what is Raoult's law? Raoult's law is nothing. It is what? It is Henry's law applied to pressurized gases, right? If I pressurize the gases, then it will become liquid, and then we have to go from Henry's law to Raoult's law. Then Raoult's law will be applicable. If I look at this Raoult's law, that means in Raoult's law we have both the liquids, and if I want to go to Henry's law, I have to convert this liquid into gas, and then we can use the Henry's law. Okay, so both of these things are very relatable. Now you will write here. Please write with me. Raoult's law becomes a special case of Henry's law in which, now here what is happening? What is happening here? The Kh it is changing to what? The Kh is changing to, tell me, Kh is changing to what? Kh is becoming equal to P naught B, right? In which, please write with me, Kh becomes equal to the vapor pressure of pure component. The vapor pressure of pure component. Okay. Can you write this down? Let me know when you're done. Is everyone done? Please tell me yes or no.
Yes, sir.
Done. Okay. So Fatima is also here now. Huzaifa, Abdurrahman. Okay. Now we will explain the one of the topics, and you will not write anything. We will first of all explain this. Okay. So one of the application of Raoult's law, it will tell me that P total of a mixture of solution, it will be equal to P naught A chi A plus P naught B chi B. Now in this equation, we have two different things. We have a LHS, which is telling me P total, and we have a RHS, which is giving me about P naught A chi A plus P naught B chi B. Now tell me which of the sides is measured and which of this is calculated. I think I told you guys this thing when we were teaching, when we were learning about Raoult's law, है ना? एक measured होता है and the other one is calculated. So tell me which one is measured here and which one is calculated? LHS या RHS? याद करके बताइए कौन सा यहाँ पे आपको? What is something that you can measure? What is something that you can measure? P total या P naught A?
P total.
P total, right? All of you agree, yes or no? Sarah, Josefa, Fatima,
Yes.
right? So P total can be measured. है ना? P total can be measured. That means if I take a container, listen very carefully. Don't write anything. कुछ नहीं लिखना है इसमें आपको, ठीक है? Please listen. You have water here, and then you have some different other liquid. Okay. Other liquid here. Similarly, you will have vapors of this, like this component. There also will be vapors due to the blue one. Okay, the blue ones. Now, since you have made this particular solution, so what do you know? You know the A liquid, you know the A liquid, you know the B liquid. That means you know what is the P naught of A. You also know what is the mole fraction of A because you have only prepared this solution. And here also you know the P naught of B, and you also know the mole fraction of B. Now, when you have these values, when you have the P naught A chi A, you have P naught B chi B, then what you can do, you can calculate the P total by plugging in the values in this part, right? By plugging in the values in this part, you can calculate these things. You can calculate. Okay. Now, also what you can do, you can put up a barometer or a manometer like this, and it will give you the measure of. It will give you the measure of P total. Okay, it will give you the measure of P total. Now, you have two type of P total. One that you have calculated, and you have not used any. You have not used any tools in order to calculate this. So I will call this as P calculated. And then you have measured the P total, and you have measured the P total. And for measuring the P total, what you have to do? You have to do experiment, right? You have to put up a instrument. You have to measure, and you have to read the whatever the pressure is. That means you are doing one experiment. Whenever you are calculating, you are not doing an experiment. You are just writing things in the paper. So I will call this as P experiment. I will call this as P experimental. Okay, P experiment. Now we have two types of pressure that we have calculated. Now both of these are claiming to be one thing. Both are telling that P experimental is saying that I am the total pressure. P calculated is saying that I am also the total pressure. So you understand this difference, yes or no? One you have calculated, the other is the experimental value. You got my point, yes or no? Please tell me. All of you?
Yes, sir.
Difference between P experimental and P calculated. Josefa, Fatima, Sarah. Now this concept, this concept of experimental and then theoretical thing, experimental theoretical. I will bring this up in the next chapter, electrochemistry. I will bring this up in chemical kinetics also. Now, what these things will do, these things will clear up a few doubts, very minute doubts that you can have. Okay, so experimental and calculated. Now there can be only two cases. If we have two things which are claiming to be the same thing. What can be the first case? The first case can be if the P experimental can be equal to P calculated. There can be other case in which the P experimental is not equal to the P calculated. There can be only two cases. Either it can be equal or it cannot be equal. Yes or no? There cannot be any third case, right? That is why if it is the first case, that means P experimental is equal to P calculated, then we say that it is ideal solution. And an ideal solution, since it is giving P experimental is equal to P calculated. And what is P experimental? That is the LHS. What is P calculated? It is the RHS. That means it is following Raoult's law. It is following Raoult's law. Now, when you read the statement for the first time, what is the ideal solution? Ideal solution is a solution that follows, that obeys the Raoult's law. क्या relation है दोनों का? Relation ये है, right? You have experimental setup. The P experimental, it is equal to P calculated. Then only it is known as ideal solution, and that because it is equal, because the experimental and the calculated values are equal, we say that it is following the Raoult's law. And the solution which don't have the P experimental, it is not equal to P calculated. That means it is not following the Raoult's law. We'll say that these are non-ideal solution. These are non-ideal solution. ठीक है, एक बात आप लोगों को समझ में आ गई? Yes or no? Please tell me. What is ideal solution? What is non-ideal solution? Yes or no, guys? Please tell me.
One that obeys Raoult's law and the other doesn't obey Raoult's law.
And you also know like what exactly things happen in order to confirm whether something is ideal or whether something is non-ideal, right? It is P experimental and P calculated. Okay. Now let us see a few different things. Okay, that will give us more insight on why does this happen. We are expecting things to be equal, लेकिन ये not equal कब हो जाता है, right? We are having some equality, we are having some expression or equation. Both of these things should be equal. The calculated one and the experimental one should be equal. But why does it happen that sometimes it is not equal? So we'll look at one of the cases. When we don't mix, when we don't mix anything, फिर भी यहाँ पे हम what I will do, I will keep this Raoult's law. It is very important. P total, it is equal to P naught A chi A plus P naught B chi B. Now, if I look at this equation only, you can easily see that the calculated part is only interested in two things. It is interested in what is A and uska vapor pressure pure में कितना होगा ना, what is the vapor pressure and pure solvent, and it is also saying what is B and what is its vapor pressure, and then they are both talking about the mole fraction of chi, mole fraction of A and mole fraction of B, है ना? अच्छा, इसका ये मतलब है A has nothing to do with B, है ना? They are taking both the things individually. They are taking both the things very individually, and I can say that this calculated part, it tells me about a situation before mixing. Can I say that? Yes or no? Please tell me. इस चीज को तो हम बिना मिक्स के भी पता लगा सकते हैं ना, both of these values. We can say that let us dissolve. Now we are not doing anything, we are just saying things, है ना? What we are saying, let us dissolve water and ethanol. Then I will ask, okay, fine, what should be the amount of water? So we will say, let us take 0.7, the mole fraction of water that I want to take is 0.7. Then what will be the mole fraction of ethanol? It will be 0.3. So we are just seeing things. We are not doing any experiment. Before mixing only, what we can do, we can calculate the P naught A chi A plus P naught B chi E. All of you got my point? Yes or no? That this part of the expression which is calculated, it is about before mixing. Yes or no? Please tell me.
Yes.
Right. Now before mixing, what happens? Before mixing, you have A. It will have interactions with other A molecules. There will be B. It will have interaction with other B molecules. But as soon as we mix them, a new type of interaction will be formed between the molecules of A and the molecules of B, AB. Okay. Now, if we have, there is intermolecular force of attraction here. There is intermolecular force of attraction here, right? And then we have intermolecular. Now, these are the intermolecular force of attraction, you can say, of before. Before what? Before mixing. Then we have new intermolecular forces of attraction. These intermolecular forces of attraction are after mixing. These are intermolecular force of attraction after mixing. These are intermolecular force of attraction after mixing. Now listen very carefully. We have two types of intermolecular force of attraction. Number one, attraction before, if it will be equal to attraction after, right? Second case can be attraction before is not equal to attraction after, and this attraction before and attraction after can also, you can write there can be two sub cases. एक में क्या होगा आपका attraction before is greater than attraction after. Second case can be attraction before is less than attraction after. Now listen very carefully. You will answer me, है ना? Please help me in this, है ना? Answer me things. Sarah, Umar, Adriel, Abdul Rahman, Fatima, Huzaifa, all of you, please. Okay, tell me. If the attraction before and attraction after are equal, that means in solution, the force of attraction between the components will be equal, and they will be escaping in the same manner as they were escaping individually. Yes or no? Just individually they were escaping, they will be escaping in the same manner afterward also. Yes or no? Please tell me. Escaping in the sense when we have liquids now. So liquids escape, they vaporize. B will also vaporize. Then what will happen? You will mix them, you will get AB. AB will also vaporize. So what I am saying, that the attraction that was present in A, attraction that was present in B, it is equal to the attraction that is present in AB. So the same way A and B were evaporating, or the same way they were escaping and they were forming vapors, AB will also be evaporating in the same manner. ये बात समझ में आई सबको? Yes or no? Please tell me.
Yeah.
Yes, sir.
Yes.
Right? Now, if they are escaping in the same manner, that means they will be producing same number of vapors before and same number of vapors after. If they are producing same number of vapors before and after, that is the vapor pressure will be equal to the vapor pressure after, है ना? So this is for before, this is for after. Now this is calculated, A के लिए अलग से, B के लिए अलग से, and this is what, this is measured ना. अब यहाँ पे जब you have AB got inside, you have AB here, then what you can do, just you can put up a manometer and then you can measure. This is giving me P total, that is calculated, sorry, this is measured or experimental, and this is the vapor pressure which is calculated. ठीक है, next से आपको ज्यादा समझ में आएगा. अब attraction before क्या, attraction after से कम है, right? So what is happening to attraction? It is decreasing. In this case, what is happening to attraction? Attraction is decreasing. Yes or no? Please tell me. हाँ या ना, सबका जवाब आना चाहिए. Adriel, tell me. Sarah, Umar, Huzaifa, Fatima, Munir. If the
Yes, sir.
attraction before, है ना, attraction is lower, then what will happen to escaping tendency? They will escape easily or not easily? They will escape easily or not easily? If the attraction is
escape
lower,
easily.
बोलिए Adriel. Fatima, Munir, if the attraction is lowered, they will escape easily or not easily?
They will easily escape.
Easily escape. Then the vapor pressure will be more or less. Then they will form more vapor or less vapor if they're escaping easily. If they're
More
escaping is more. If they're escaping easily, they will form more vapor. That means the vapor pressure will be.
high.
That is why P total is greater than P naught A chi A plus P naught B chi B. Because in the solution, what is happening? In the solution, what is happening? The pressure is increasing. If I compare that with the individual cases, है ना, individual cases. Similarly, in this case, what will happen? Attraction after is increasing. If attraction after is increasing, then what will happen to the escapability? Escapability, like the escaping tendency will decrease, and if the escaping tendency decreases, the vapor pressure will also decrease. The vapor pressure will also decrease. Okay. So here you have ideal solution, non-ideal solution. Okay. And then in non-ideal solution also there are two different cases that we will also look. Okay, that we will also look in that. चलिए अभी तक तो हम क्या करते हैं, एक और चीज हम लोग समझते हैं. We'll understand one more thing here. What we'll understand? See, Let us do one thing. Let us write, okay? आपको बहुत समझा लिया, अभी लिखते हैं. उसके बाद when we will be dealing with non-ideal one, then we can just write it down. Let us write ideal and non-ideal solution. Ideal and non-ideal solution. Okay. So what is ideal solution? Ideal solution.
The solution that obeys Raoult's law.
A solution which obeys Rod's law. A solution which obeys Rod's law over the entire range of concentration is called ideal solution. तो ideal solution में characteristic क्या होती है? That the pressure due to A will be equal to P naught A chi A, and the pressure due to B, it will be also equal to P naught B chi B, and eventually the P total will be equal to P naught A chi A plus P naught B chi B. Okay, so this is the basic case. And in ideal solution, what is going to happen? The attraction between, that means attraction before and attraction after are equal. उसी को अच्छे line में क्या लिख सकते हैं हम लोग? We can write that attraction between the molecules of individual component will be the same as the attraction after mixing in the solution. Okay, so what we will write here? We will write the attraction between molecules of individual component individual components will be same as the attraction after mixing in the solution. Okay, in the solution. Now let's write AB interaction, AB attraction is equal to AA and BB. Okay, AB is equal to AA and BB. Okay, इसको याद रखिएगा हमेशा. Then all of you, yes or no, please tell me. आगे बढ़े?
So wait, sir.
Characteristics of ideal solution. Okay, so the first thing that you will write is volume change on mixing is 0. And now why is the volume change in mixing is 0? Because if the attraction is equal, that means what? the molecules will be separated in the same distance, right? If they're separated in the same distance, they're occupying same space, they're occupying same volume. Is that clear? Yes or no? Please tell me that the volume change of mixing will be equal to 0 because the forces of attraction is not changing. If the forces of attraction is not changing, the distance between two molecules will not change, and that is why the volume will not change. Yes or no? Abdurrahman, Adriel, Fatima, Sarah, tell me. Is that clear? Volume mixing will be 0. Yes or no?
Yes, sir.
Okay. If V1 and V2 are the volumes of individual components then what is going to happen? Then the volume of solution will be V1 plus V2. ठीक है, V1 plus V2. इसका क्या मतलब हुआ? मतलब हुआ the change in volume after mixing, it is equal to 0. It's one of the confusion point that you have to remember. Okay. Second is heat changes on mixing is 0. That means there will be no heat required. There will be no heat required, or the net heat exchange in mixing will be equal to 0. Now, when AB attraction is equal to AA and BB, that means what is going to happen? The amount of energy you are giving in order to break the AA and BB bond, and then you are forming AB bonds, right? You are forming the forces of attraction, which is AB. Both of these things are equal. So the amount of energy you're giving as input, it is coming at output, and the energy is being released. Right, the energy is being released. In order to understand that, you can write, see, AA plus BB will give me AB plus AB, and I want to break these, and I want to form these, right? So breaking will also require energy, forming will release energy. So the amount of energy that I am giving in order to break these bonds, it will be equal to the amount of energy that is being released after the formation of AB bond, because the amount of energy required to break will be directly proportional to the nature of attraction. And if we look at nature of attraction, the nature of attraction is equal. That is why we will be giving some amount of energy, and the same amount of energy will be released, because we are breaking and then we are forming, and that is why the heat exchange will be equal to 0. So you will write here, when there is no change, when there is no change in the intermolecular force of attraction, the intermolecular force of attraction, the molecular force of attraction on mixing two components, then the enthalpy of mixing will be 0. शॉर्ट में कैसे लिख सकते हैं इसको? डेल्टा H of mixing will be equal to 0.
Also, can you zoom out
Which part do you have to write?
volume?
Why have you not written? आप साथ साथ लिखा कीजिए ना. Explain तो हम कर ही देते हैं पहले. Those who have written, you will write example, and you will remember these 3 examples. Okay, these 3 are very easy examples. Number 1, benzene and toluene. If you look at the intermolecular force of attraction, both of them has London forces. Okay, and both of these are non-polar, and that's why पहले यही आइडेंटिफाई कीजिएगा आप लोग कि क्या है, non-polar and non-polar, right? Both of these are non-polar. That is why they will be having London forces or dispersion forces. Second is N-hexane and N-heptane. Normal hexane and normal heptane. Normal hexane and normal heptane, again these are non-polar, right? These are non-polar. And third is you have chloro, ethane and bromoethane. Both of these are polar molecules. Okay, both of these are polar molecules. Fourth में आप एक और example लिख सकते हैं, phenol and aniline. So phenol and aniline, what happens? You have in both the cases hydrogen bond. And what is happening after that? Even if you mix them, then also you will be forming more and more hydrogen bonds only. Okay, you can keep them as ideal solution.
Sir, what is the first one? Benzene and
अच्छा, benzene एक सेकंड चाहिए, इसको आप रहने दीजिए अभी, लेकिन aniline इसको ना हाइड्रोजन बॉन्ड वाले को बाद में दिखाएंगे. Wait a second. Yeah, benzene and toluene. Toluene पता है ना? Toluene is just benzene with one CH3 molecule here. This is toluene. This is N-hexane. This is N-heptane.
Sir, the N means that all the carbons
Normal.
in the straight line, right?
Yeah, straight line, correct. Normal. Yes. Yeah, chloroethane and bromoethane. Both of these will be polar. Done?
yes, sir.
Okay. Now moving on. Negative deviation, or sorry, non-ideal solutions. Sorry, non-ideal solutions. Now, in non-ideal solution, the solution which do not obey Raoult's law over the entire range of over the entire range of concentration. So please write the solutions. This do not obey Raoult's law over the entire range of concentration. अच्छा, ये भी हम आपको बताते हैं entire range of concentration क्या मतलब है. You all know that P total is equal to P naught A chi A plus P naught B chi B. इसका मतलब ये है, if I start here from 0.1, ठीक है, तो 0.2, 0.3, 0.4 to 0.99 है ना, then over the entire range of concentration, if it is following the Raoult's law, then it should follow the Raoult's law in all of these concentration. So entire range of concentration का मतलब यही है. It's not that कि P naught A और chi A and chi B if it is 0.5 बस वहाँ पे काम कर रहा है, and in all the other concentration, the Raoult's law is not being followed, that means it will be non-ideal only. Okay, so the entire range of concentration means from 0.1 से लेके बिल्कुल आपका आखिरी तक, है ना? It should be following Raoult's law, then only it will be ideal. कहीं पे भी अगर उसने follow नहीं किया तो it will be non-ideal. So the solution which do not obey Raoult's law over the entire range of concentration, is called non-ideal solution. इसमें क्या होगा? जो pressure due to A, vapor pressure of A will not be equal to the theoretical value that P naught A chi A. P naught B will not be equal to, sorry, pressure due to B will not be equal to P naught B chi B. And eventually, P total will not be equal to P naught A chi A plus P naught B chi B. In this case, what we can write? AB attraction is not equal to AA and BB attraction. Okay, it's not equal to AA and BB attraction. Furthermore, if AB attraction is not equal, then also we can write about characteristics. So in characteristic, what we can write, the first point will be the change in volume will be non-zero, है ना? Change in volume will be non-zero. Non-zero का मतलब delta V of mixing will not be equal to zero. Second point will be heat change will be non-zero, है ना? इसका मतलब the delta H mixing will not be equal to zero. Actually, please write this down. If you have doubt in any one of these points or characteristics, please let me know. Okay. Now we'll look at the types of non-ideal solution. It can be positive also. It will be non-zero. Okay, non-zero means positive, negative कुछ भी हो सकता है, zero नहीं होगा बस. When we will look at the types of ideal solution, then we will explain more. Done all of you, yes or no? Please tell me. Can you please turn the mic on, Umar?
Done, sir.
Okay. Umar, can you please turn the mic on?
Yes, sir.
Which notebook you are comparing with?
My school notebook.
School notebook. What is the topic there?
non-ideal solution.
Just non-ideal solution.
Yeah.
Nothing else. हाँ तो
2D
उसको कॉपी को उस नहीं आई मीन द केस विच यू आर टेलिंग इट कैन बी अ केस बट उसका नाम अलग से रहता है, टॉपिक अलग से होता है ना. सो मैं एक तो इफ यू आर कंपेयरिंग ना तो किसी के दूसरे की नोटबुक से तो कंपेयर मत कीजिए. ओके. अदर थिंग इज दैट इफ यू वांट टू कंपेयर यू कैन कंपेयर एंड यू कैन कीप एनसीईआरटी टेक्स्ट बुक विद यू. ठीक है. ओके है ना. एंड furthermore I will tell you that don't have more than one notebook है ना when you are attending any of the lectures. या तो आप स्कूल में भी अगर अटेंड करें तो जो टीचर पढ़ा रहे हैं तो उसकी पढ़िए है ना. एंड इफ नॉट तो फिर आपकी मर्जी है. डोंट कंपेयर नोटबुक्स ऑफ टू डिफरेंट टीचर्स है ना. उसमें क्या होता है कि आप क्या लिख रहे हैं, मतलब अब किसको ब्लेम किया जाए है ना. टीचर को हम ब्लेम करें जो इतने सालों से केमिस्ट्री पढ़ा रहा है, या आपको हम ब्लेम करें जो लगभग लास्ट कुछ सालों से ही नोट्स लिखना सही से चालू किया 9th क्लास के बाद से है ना. तो ये भी हो सकता है कि आपने कुछ गलत लिख दिया हो. राइट. सो ऑलवेज हैव एनसीईआरटी इफ यू वांट टू कंपेयर. चलिए. नाउ टाइप्स ऑफ नॉन आइडियल. And Umar, this is for everyone. Rather than getting into these things, na, you should start solving questions of NCERT. Types of non-ideal solutions. Now these things can also help you, है ना. ये नहीं हम कह रहे कि ये सब चीजें हेल्प नहीं करेंगी. हेल्प करेंगे लेकिन मार्क्स लाने में हेल्प नहीं करेंगी. बस ये बात है ना. Whenever you are putting effort in anything, it is obviously going to help you, है ना. शायद इससे कुछ आपका you can get some insight about your personality है ना. कि बहुत सारे होते हैं जो लोग प्रूफ रीडिंग वगैरह में अच्छे होते हैं है ना. So it can help you but not in gaining marks. Gaining marks अगर लाने हैं उसके लिए आपको क्या करना पड़ेगा. NCERT practice. First of all you have to practice NCERT. Types of non-ideal solution. Now we have already seen that for non-ideal solution the P total should not be equal to P naught A chi A plus P naught B chi B. It can only give me two cases. A case where the P total will be greater than P naught A chi A plus P naught B chi B, and there can be a case in which the P total is less than P naught A chi A plus P naught B chi B. Okay. Now there are simple names for this type of deviation. So it is showing deviation from Raoult's law. Both of these things are showing deviations from Raoult's law. The names of these are very simple. If you remember it from the perspective of pressure, है ना. Pressure की perspective से याद कीजिए. So the case where you have P total which is greater than the P naught A chi A plus P naught B chi B, it is known as positive deviation from Raoult's law. This is positive deviation. And when you have P total which is less than P naught A chi A plus P naught B chi B, this is known as negative deviation. This is known as negative deviation. Okay, known as negative deviation. Okay. Now we will explain and we will look into it individually also. Usse pehle I am going to give you some idea about these things, है ना. Some idea about both of these things. Now first of all, if the P total, now please you will answer me. Okay, आप लोग एक तो आंसर नहीं करते, मन करता है कि ऐसे निकल के बिल्कुल आगे निकल जाए. ठीक है. Please answer me. If P total is greater than P naught A chi A plus P naught B chi B, what does that mean? If the pressure is more, then there will be more vapor pressure or less vapor pressure. Tell me, the vapors will be more or less?
More.
Okay, we will have more vapor. If we are having more vapors, that means they are escaping easily or not easily? They are escaping easily. If they are escaping easily, what does it tell me about the intermolecular force of attraction? Will it be higher or lower? Lower. Okay. Similarly here, if the P total is less, that means we will have less vapor, right? And the gases are escaping not easily, and then it means the IMF of attraction in these type of gases, sorry, in this type of solutions will be higher after mixing. Okay, after mixing. Now we will first of all look at the explanation of positive deviation. Okay, we'll look at the explanation of positive deviation, and we will look at this from the perspective of an example. Explanation of positive deviation. देखिए एक और चीज हम आपको बताते हैं जो साइंस में बहुत ही इंपॉर्टेंट है, जिन चीजों के बारे में आपको जिनके बारे में आपको फर्क पता होना चाहिए. ठीक है, there are two things. One is known as the reason and the other is known as indication. One is known as reason, the other is known as indication. ठीक है, reason और उसके बाद क्या है, indication. All of you know that silver test, yes or no, please tell me. Silver test आप लोगों ने कभी किया है? अच्छा, have you performed any test in class 11? कोई भी chemical test? Yes or no, please tell me.
No, sir.
Salt analysis.
Salt analysis you have done? कौन
Yeah.
सी salt का बताइए, किसी एक salt का.
I don't remember.
हाँ, don't remember. अच्छा.
So do you mean like anions and cations?
हाँ, anions and cations, उसी में बात, उसके बारे में बताइए कुछ. What do you remember? Anything?
Red bromide.
What?
Red bromide.
Bromide. So what was the, like, how did you know the bromide is present?
First there was pungent smell, the brown gas, and then there was, I think it was white or yellow precipitate. I don't remember.
Why do you? ठीक है, ठीक है. So you remember, now you have to identify there are two different things. ठीक है. So the indication will be, what did you say for bromine? Tell me. What should happen in bromine? If you have bromine, then there will be. If you have bromine salt, if you have bromide salt, है ना, या फिर bromide है अगर आपकी किसी चीज में, then what is the indication? Brown कुछ तो कहा था ना आपने, ये सुनो. And now they are not speaking. Now they are not speaking. Hey, let me tell you about a very famous one, that is for what? Copper. Okay, if you have copper, then you will get blue type of precipitate which is surrounded by I think green or yellowish green type of color. Okay, then there is another one which is of I think it is Pb2 plus. This is Pb2 plus, and it is like bluish white type of color is there. Okay, bluish white type of color is there. Now these all things are the color that you are telling na, these are the indication that you have copper and you have Pb2 plus. Okay, is an indication. Now what is the reason behind this indication? The reason is that you have copper or you have Pb2 plus. Okay, so reason and indication. So indication is something that you can see, that you can smell, है ना, that you can take inside your head. आप उस knowledge को कैसे gain करेंगे? You will gain that knowledge of indication by your five senses. और जो reason क्या होगा? The reason will be, you can't see the reason. You can never see the reason. The reasons are always in the molecular level or the atomic level. यहाँ पे देखिए जो positive deviation है ना, the positive deviation that we are having, it has two things here also. What is the indication? The indication that is that P total will be higher. अब जो P total higher है वो आपको barometer दिखा रहा है, आप अपनी आंख से देख रहे, that is one of your senses. But what is the reason behind P total? It is the intermolecular forces of attraction that you can never see. You guys understand the difference between indication and the reason? Yes or no, please tell me. Yes or no, please tell me. Indication and reason. You understand the difference between indication reason in this particular case of positive deviation and negative deviation? यहाँ पे indication क्या है positive deviation का? That the P total will be higher, and the reason for that is intermolecular force of attraction will be lower. Okay? अरे हाँ या ना, कुछ तो बोलिए, क्या हो जाता है आप लोगों को?
Yes, sir.
Yes, sir. Now, let us look at the explanation of positive deviation. The example is ethanol plus cyclohexane. Ethanol is C2H5. OH कोई लिखेगा नहीं. And cyclohexane is C6H6. So नहीं, C6H12. ये आपका इस तरह का स्ट्रक्चर होता है, right? Now, the force of attraction, if we just look at ethanol, individually, in a container, and we have cyclohexane in a container. If we just look at ethanol, there will be hydrogen bonding. If you just look at cyclohexane, it is non-polar, and that is why it will be having London forces or dispersion forces. ठीक है? Now please listen very carefully. If I am going to mix these two, we have ethanol. ठीक है? We have ethanol, and in that ethanol container, each and every molecule of ethanol is connected through hydrogen bonding. Each and every one molecule is having at least one hydrogen bonding. Okay, so we have complete solution. It is connected. The molecules are connected through hydrogen bonding. Now what did I do? I added some cyclohexane. It will take some space, right? It will take the space between ethanol molecules. It will take this. Now we are doing what? We are mixing it. We are making a solution. So cyclohexane will be present uniformly everywhere. That means it will be taking some spaces between the ethanol molecule, and that is why it will be disturbing the hydrogen bonding in ethanol. Yes or no? Cyclohexane, if we add cyclohexane on ethanol, it will disturb the hydrogen bonding. Yes or no? Please tell me. Yes or no? नहीं आया समझ में किसी को? Sarah, Fatima.
Sir, could you repeat again?
What did I say? You repeat. आपने सुना नहीं? आपने सुना नहीं या समझा नहीं, वो हम देखना चाहते हैं. If you have listened, tell me what did I say?
When we add cyclohexane into ethanol, will there be change?
Will there?
Will there be change in the hydrogen bond?
Change नहीं, disturbance हमने कहा है ना, right? Now tell me.
Yes.
Think. In ethanol, what do we have? What is the intermolecular force of attraction in ethanol? Only hydrogen bonding, yes or no?
Yes, sir.
Okay. Now when we are going to add cyclohexane, it will take some space, yes or no?
Yes, sir.
It will take some space between ethanol molecules, yes or no?
Yes.
Now when it is taking space between ethanol molecules, अब जो पहले जिन दोनों के बीच में हाइड्रोजन बॉन्डिंग था, वहां पे बीच में आ गया साइक्लोहेक्सेन. So hydrogen bonding will be broken.
Yes.
Correct? So that is what I am saying. देखिए, जिन लोगों को पढ़ना है, अगर if you are going to be silent, और इस बैच में है ना, if you want to learn, then you have to either shift the batch. कि अगर आपके बैच में कोई कुछ नहीं बोल रहा है, तो उसमें कई बार ऐसा होता है कि the teacher unknowingly they will not tell you something. ठीक है, और उसका आपको पता भी नहीं चलेगा. There are some important points. जब वो तभी याद आता है जब बच्चे कुछ बात पूछते हैं, जब बच्चे कोई डाउट लेके आते हैं, है ना. If you guys are not speaking, then ऐसा नहीं कि सारी की सारी चीजें आपको पता चली जाएंगी. ठीक है. So there are some things that only come out of the mouth from teacher जब कोई बच्चा कुछ बोलता है. इस वजह से सारी क्लासेस अलग होती है ना. Even though the notes are same and everything is same, but still there are, वैसे तो एकदम रेडियो की तरह नहीं निकलता टीचर का. It depends on what type of student is there and what the students are asking. जिनको पढ़ना है ना, so they please speak up, otherwise the whole batch suffers. ठीक है. चलिए, हाइड्रोजन बॉन्डिंग, लंडन फोर्सेस. और देखिए, हम तो सीधा बोल रहे हैं, हमको भी मजा नहीं आएगा, हम चुपचाप पढ़ा के चले जाएंगे. ठीक है. एंड इट्स नॉट लाइक दैट कि और बैचेस नहीं है ना. देयर आर मेनी बैचेस. यहाँ पे हम पढ़ा के फिर चले जाएंगे अगर आप लोगों ने बोलना चालू नहीं किया तो, है ना. Now this I say like very rarely. I'm very sorry to say that. Like हमको भी खराब लग रहा है बोलने में, but it's not like धमकी हम दे रहे हैं क्या? नहीं, धमकी तो हम नहीं दे रहे हैं. वो बिल्कुल क्या बताएं, इनवॉलंटरी मसल्स जैसे होता है ना, उसकी तरह काम होता है वो. ठीक है, हाइड्रोजन बॉन्डिंग, लंडन फोर्सेस. So hydrogen bonding will decrease. Now what is happening when we are mixing these two things? Hydrogen bonding is decreasing. That means intermolecular forces of attraction decreases. Okay, intermolecular forces of attraction, it will decrease. Now what we can write? If the intermolecular forces of attraction will decrease, then what is going to happen? Then escaping will be easy. If the escaping is easy, then what is going to happen? More vapor and more vapor pressure also. More vapor and there will be more vapor pressure. That is why we will having positive deviation. So you can write here, after mixing, the extent of hydrogen bonding of ETOH will decrease, right? It will decrease, and as intermolecular force of attraction decreases, what is going to happen? As intermolecular force of attraction decreases, there will be increase in vapor and increase in vapor pressure. Second point, the V final, since the attraction is decreasing, it will be taking more and more space, will be greater than the V initial. And we can say that delta V of mixing, it will be equal to positive. Now that means delta V of mixing will be greater than 0 in the positive deviation. Now next thing is that what will happen to the delta H of mixing? So delta H of mixing, as we can see, intermolecular force of attraction is decreasing. That means the amount of energy released, it will be much less than the amount of energy we are putting in order to break the bonds, right? So we are going to have delta H of mixing, it will be positive. That means mixing will be exothermic. Mixing will be exothermic. The next topic, that is graph for the deviation. And which deviation? Positive deviation. In graph for the positive deviation, so we have to compare the positive deviation with Raoult's law. So the graph will be similar to Raoult's law, but there will be some changes here. So the changes that will be taking place, some things will be similar, obviously. We'll first of all put up the ideal situation, and then we will put up the positive deviation. So we all know that in Raoult's law, it is pressure here, and chi b is plotted here. There are lines like this, which denote the chi pressure of A, pressure of B. Similarly, we can have a line like this. There will be a line. This is all ideal situation. So everything here, whatever we are writing, it is ideal solution. Raoult's law is followed. Now, when the Raoult's law will not be followed, then what is going to happen? And this is P total. So let's just I think this will be P naught A. This will be P naught B. Okay. Now, this is the line. This is the line for the positive deviation. Why? Because you can see this is the ideal line and the pressure is higher than the ideal situation, right? The pressure is higher. Now this higher pressure, it is indicating that it is the plot for positive deviation, the plot for positive deviation. Okay, so please write this down. Then you will also see that P naught A will be higher than the ideal situation like this. Similarly, the P naught, sorry, the plot which is representing the PB and PA, it will also be higher. Okay, so both of these things are there. So in all of these cases, you can see that the pressure for individual A and individual B is also increasing. The pressure total P total is also increasing. So this is the positive deviation and the graph of positive deviation. Write this down. You just have to make the graph for ideal situation. That means you have to make the graph for Raoult's law. And if it is positive deviation, then you have to just make a curved line which is above the ideal situation for all of the three lines. For the P total, for the PA, and for the PB. The other things everything is same. And we can all detail यहाँ पे आप लिख सकते हैं. Chi B is equal to 0, chi A is equal to 1, chi B is equal to 0. Chi B is equal to 1 and chi A is equal to 0 यहाँ पे. Okay, so all of these things you can write. Now write the explanation for negative deviation. Explanation for negative deviation. The example that we will be looking here is acetone and chloroform. Acetone and chloroform. The structure is important. So acetone is a carbon with a double bond with two CH3 groups. And there is a hydrogen which is connected to carbon in chloroform. This carbon is further connected to 3 chlorine atoms. This is the structure for chloroform. If I look at the individual molecules, there is acetone, it is polar. Why it is polar? Because carbon is having delta positive charge and oxygen is having delta negative charge by the virtue of their electronegativity difference. If I look at this chloroform, this is also polar. Now, how is this polar? In this, all the chlorine atoms, it is attracting electrons from carbon, and the carbon is getting delta positive charge. And since you have a positive charge in a particular atom, this carbon will be attracting more and more electron from hydrogen, which will give this delta positive charge on this hydrogen. So both of these molecules are what? Both of these molecules are polar, which are having dipole moment in this direction. Right? In this direction, the dipole moment is present. Now, when we are going to mix these two things, then what we are doing? We are mixing these two, right? We are mixing these two, acetone and chloroform. As you can very clearly see, that oxygen, it is having delta negative charge. It will also be having some lone pair electrons. These lone pair electrons, it will be interacting with the delta positive of hydrogen. Now, since we have very high delta positive charge, the interaction here, it will be equivalent to a hydrogen bonding. Okay, equivalent to a hydrogen bonding. Now, hydrogen bonding is also what? It is a very extreme case of dipole moment, very extreme case of polar interaction. And so the polarity is so high. We have oxygen already here with its lone pair and hydrogen, which is having a high delta positive charge by the virtue of these 3 chlorines. So what we are forming? We are forming a completely new intermolecular force of attraction, that is hydrogen bonding. That is hydrogen bonding. Okay. Now this hydrogen bonding is what? This hydrogen bonding, it is completely new. And if we are forming hydrogen bonding, then what is we can say? We can say that after mixing, intermolecular forces of attraction increases, right? Intermolecular force of attraction increase, and that is why what will happen if the intermolecular force of attraction will increase, the intermolecular force of attraction will increase, the escaping tendency, it will be lowered. If the escaping tendency is lowered, then what is going to happen? The vapor pressure we will be having low and low vapor pressure, right? Low and low vapor pressure. So you can write a few points here only. First thing that you will write here is, when is H bonding formed? Hydrogen bonding is formed only after the mixing, right? H bonding is formed after mixing. It is formed after mixing. And what is going to happen? Hence, the attraction increases leading to decrease in vapor pressure, and that is why in this case the PA, it is what, lower than P0A chi A, and PB is also lower than P0B chi B, and eventually P total will also be lower than P0A chi A plus P0B chi B, P0 plus P0B chi B. Now the two other things that we can also write here is regarding the volume. So in this case, the volume final, it will be what? Since what is happening, the attraction is increasing. So after mixing, attraction is increased. The distance between two molecules will also decrease, and hence the volume will also decrease. So V final will be less than V initial, and that is why the delta V of mixing, it will be what? It will be negative. V final is smaller. That is why it will be negative. Now the last point that we can write is about the H of mixing, delta H of mixing. Now what is happening? The intermolecular force of attraction is increasing. So after mixing, we are forming more and more attraction. If we are forming more and more attraction, then we are releasing more and more energy. If energy is released, the mixing will be exothermic. Mixing will be exothermic. Okay, mixing will be exothermic. And that is why delta H of mixing will be equal to negative. Okay, so these are the points for negative deviation. Please write this down. Then we'll do graph also. Copy कर लेते हैं बाद में paste करेंगे. Yeah, please write this down. Done. Okay, so this is now graph for negative deviation. Okay, so look at the graph for negative deviation. So in this case, what will happen? All the pressure, it will be lower than the ideal case. It will be lower than the ideal case. So the P total will also be lower than the ideal case. Then the PA will also be lower than the ideal case. The magnitude थोड़ा ज़्यादा हो जाएगा. How to write these things? इसको कर लेते हैं पहले. देखिए उल्टा हो गया ना, लोअर होगा, लोअर, ओके। Okay, so that is it that you have to write. It will be lower than the ideal case. Done, yes or no? Please tell me. Now there is a concept that is known as distillation. Okay, so since we are learning about mixtures and solutions, it is not that we always prepare solution, है ना? ऐसा नहीं है कि we always prepare only. Now many a times what happens in nature also, and while we are doing some type of chemical reactions, we take A plus B and then we are getting C and D. Now both the C and D, they are in aqueous state, and we have now we don't, what we have here, we have a solution here that is of C and D, and we need only the D product. C is not important to us. Then what we need to do, we need to extract D, right? Need to extract D, or we need to purify this particular solution. We need only D from here. One of the easiest method is distillation, that you must have heard of. Distillation, like in your lower standard also, you must have heard of distillation. What is the concept of distillation, and what is the basic principle of distillation? See, the basic principle of distillation is, now if I tell you the procedure, it will be helpful, that we have some type of round bottom flask and we heat it, right? And this flask, it goes above, and then here you will have some type of cork, and then there will be some, this type of situation is there when you have distillation apparatus, right? So here you will cool the, here you will inlet and outlet will be there, right? And then you will get each and every drop. Okay, you will get each and every drop. So this is kind of how distillation happens. It's a kind of how distillation happens. But what is the basic funda? What is the basic fundamental difference between the two solutions which is leading to the distillation? So let us suppose we have A solution and we have B solution. Now obviously in distillation we have to boil things off, right? We will boil, right? We will heat something. Let us suppose if you are boiling, that means A will have some temperature which is 100 degrees Celsius, its boiling temperature, and let us suppose B is having 200 degrees Celsius. The boiling point of A is 100, for B it is 200 degrees Celsius. Now, in this case, what is going to happen? When we are heating something, then the temperature will go from 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Now, as soon as 100 will reach, A will start to boil off. Now, please remember, even though we are heating, still the temperature will not increase, right? The temperature will not increase. Why? Because of latent heat. Latent heat of vaporization. Latent heat of vaporization says that if we apply more and more heat at a boiling temperature, then the heat is not consumed in order to increase the temperature. Rather, all the heat is consumed to evaporate. All the heat is used to convert the liquid to vapor. So once we have reached 100 degrees Celsius, A will start to boil off, and the temperature will be 100 degrees Celsius. It will be not changing. Now slowly A will be starting to boil off, and A will be completely gone. Now when the A is completely vaporized, then the temperature will start to increase. So now the indication here is what? The indication here is a rise in temperature from 100 to 120, 110. If the temperature rises from 100 to 110 or 120, that means all the A has been boiled off. And then what we can do, we can take the container that we have, we can turn off the heating, because we have already got the vapors of A, and the vapors of A, they will slowly condense and they will be collected in the liquid. Now, what is the basic difference between A and B? There is a difference in the boiling point. Right? If there is no difference, for example, if we have two different molecules or two different liquids, let us say P and Q. P has 100 degrees Celsius and Q has 105 degrees Celsius, right? Now, when you have 100 degrees Celsius and 105 degrees Celsius, now the chances of Q molecules also getting evaporated at 100 degrees Celsius is very high. That is why even if we reach 100 degrees Celsius, then we cannot see that the vapors which are forming will be only of P, because there will be some vapors which will be forming for Q also, and that is why we will be getting contaminated water. So the basic point is, whenever we want to distill something, then the mixture should have boiling point of A and boiling point of B. That means at least there should be two boiling points. There should be two boiling points for compound A or compound B, component A and component B. But if I look at the case of acetone and chloroform, acetone is polar, chloroform is also polar. When we mix these two things, what is going to happen? This will be forming hydrogen bond. Now, acetone will have some boiling point, which will be from the fact that it is polar. Similarly, chloroform will also have some boiling point, which will be from the fact that it is polar. But when I mix these two things, I have a completely new intermolecular force of attraction, and the boiling point of solution will neither depend on what is the boiling point of acetone or what is the boiling point of chloroform. The boiling point of solution will be dependent on hydrogen bonding, and that is why this solution will have only one boiling point. It will have only one boiling point, right? The complete solution will boil at one temperature. अब जब एक ही temperature में boil कर जा रहा, कोई दूसरा temperature है ही नहीं, then we cannot distill these type of things, right? We cannot distill these type of things, and these are known as azeotropes. The solutions or the mixture which have only one boiling point, which boil at a constant temperature, these are known as azeotropic solution, or these are also known as azeotropes. So since here we have two different type of azeotropes, अब इसी केस में देख लेते हैं, we have acetone and chloroform. We had polar, and now the hydrogen bonding is present. So obviously hydrogen bonding is there. That means attraction is increased. If the attraction is increased, that means it will require more temperature to boil off. That is why the boiling point will be higher. And if the boiling point is higher, it is known as maximum boiling azeotrope. Okay. So write the next topic here. Azeotrope. Or it is also known as constant boiling mixtures. Okay. Now, okay, there can be two different type of azeotropes. Some of the azeotropes, they boils at higher temperature than component. Okay, higher temperature. So at higher temperature, that means it is maximum boiling azeotrope. Okay, it will be maximum boiling azeotrope. And there will be some which will be boiling at lower temperature than the components. Boils at lower temperature than component. Okay, this will be what? This will be minimum boiling azeotrope. Minimum boiling azeotrope. This will be minimum boiling azeotrope. Okay, since we have this as minimum boiling azeotrope, now what else we can write about this? Boils at higher temperature than the component, and since it is boiling at higher temperature than the component, that means intermolecular forces of attraction increases. If intermolecular force of attraction will increase, the things it will not escape easily, and that is why the vapor pressure will be lower. The vapor pressure will be lower. And if the vapor pressure is lower, that means it is shows negative deviation from Raoult's law. Now all the cases will be opposite for the minimum boiling azeotrope. Okay, intermolecular force of attraction will be lower because it is boiling at lower temperature. Vapor pressure will be higher and it will show positive deviation. Intermolecular force of attraction, it will be what? It will be lower, because it is boiling at lower temperature. Vapor pressure क्या हो जाएगा? High हो जाएगा because intermolecular force of attraction is lower, and that is why it will be showing positive deviation from Raoult's law. चलिए write these points azeotropes के बारे में. Also write one more thing, जो definition लिख लेते हैं azeotrope का. What are azeotropes? The mixtures that boil at constant temperature. Acha, there is one more announcement. In a week or two, you will have extra classes. Okay, and extra classes will be for chemistry. There will be one per week. For JEE and NEET. Okay, for JEE and NEET, and we have got a IITB. He is a BTech from IITB. His name is Mohit sir. Mohit Syal is an experienced faculty, and he will also give you a he will tell you about JEE and NEET, how to deal with it also, and also he will be more focusing on the JEE topics and the NEET topics and the topics and the questions which come and which are off JEE and NEET and which are like JEE and NEET. So he'll be mainly teaching about